This is Myles from Station 103. I'll be reporting on the basics of fire behavior. Today we're going to talk about what makes a fire work, as well as how to put one out. Let's start with the difference between fire and combustion. Fire is a type of combustion. There are many types of combustions, ranging from the forming of rust and breathing oxygen to more fast-paced combustion like fire and explosion. Basically, fire is a self-sustaining combustion reaction, yielding heat, light, and products that allow for the combustion reaction to continue. Now, come on, let's take a closer look at what makes a fire burn. According to the fire triangle, 3 things are necessary for a fire to continue combustion: heat, fuel, and an oxidizing agent, usually oxygen. Removing just one of these elements will extinguish the fire. This also works the other way around. We are going to add sufficient amounts of each of these 3 essential elements and get combustion. So for fuel, we're going to use this paper bag right here. This means we'll be creating a small Class A fire, a fire that burns from ordinary combustible materials, such as wood, paper, or rubber. This type of fire is more predictable than the other classes and is perfect for demonstrating. For an oxidizing agent, oxygen will work just fine. So now that we have our fuel and our oxygen, we're going to add the heat. We're going to use a lighter for the heat, which is a pre-mixed flame. It mixes a ratio of fuel and oxygen for the desired flame. This is fire at work, a self-sustaining combustion reaction yielding heat, light, and flame at varying intensities. This is just going to be a small one and will extinguish itself once the fuel runs out.
You let me violate you.
The fire triangle is pretty useful to explain the basics, and a Class A fire is pretty good subject for testing. But there are also Class B, C, D, and K. Each one can be life-threatening hazard. Methods that will extinguish Class A fire can make Class D metal fire a lot worse. For this reason, the industry has developed the fire tetrahedron. The fire tetrahedron identifies the 4th essential element of the fire, the uninterrupted chemical reaction. Just like the fire triangle works, if you take out the chemical reaction in the fire tetrahedron, the fire will also go out. Okay, so let's take what we learned from the fire tetrahedron and try to extinguish a fire by removing just this 4th element. We're just going to use a candle this time, but watch what happens when my lab partner activates the halon gas. And that's why the fire tetrahedron makes sense. We just put out a fire not by removing the fuel, oxygen, or heat, but by removing the chemical reaction. That concludes this report from Station 103. I hope you've taken a lot out of this. Tune in again for all of your fire safety thirst.